Rip ears. Rip ears, chat. Sorry if I... I had the audio up probably like 3 times higher than it should have been. Thank you. Thank you for the cat mode. Thanks, Ash. Nya. Nya. I hope everyone's had a good Friday. I had a Friday that was enjoyable, but also I know future Belle will regret this. I stayed up last night for no good reason. For no good reason. I was supposed to start doing homework last night, and I was like, nah, it's not due until Saturday night. And so I did art instead, and next thing I knew, I looked at the clock and it was 4 a.m. 4 a.m. So, of course today, my body woke me up at like normal wake up time for work, which is like 9-ish. And then I was like, nah, I'ma stay in bed because it's my day off. And then I closed my eyes, and I opened them back up again, and it was fucking noon, chat. It was noon, chat. Wait, mouth? Model? What? Okay, just making sure my tracking's still good. I woke up at noon, chat, and I was like, okay, it's fine, I didn't do any of the homework last night, I can do it now. And I can spend a couple hours doing it now, and I'll do it now. And then I can stream tonight. And then I got a fucking Discord message as I was getting out of bed from my old friend who I used to play MMOs with. You know, like WoW and the likes. And he's like, hey, Belle, I need you to come check this app I wrote for the game that we used to play. It reads screenshots of items and tells you like how good their value is. I need you to come test this for me. So I hopped on Discord because I hadn't talked with him in like forever. It must have been like 6 months since we hung out, because even back when I was playing that game, he really wasn't. But it was cool to just hang out with him. So we started like fucking around with his new like app on this game that I haven't played in like months and months. And suddenly it was like this rabbit hole of, oh, well, I found this bug, and this bug, and this bug. We have to find them all. We have to find everything that will brick your app. And then it just turned into this exhaustive search of other of the people we used to play with hopping into Discord and like, oh, what are you guys doing? Blah, blah, blah. And then we'd talk with them and we'd be like, yeah, we're messing around with this app he wrote that reads screenshots of the game and then tells us, you know, which item is better. We're looking for things that break it. And then, you know, we had all these old people from our old raid group, you know, like on the Discord, submitting images, trying to break things, finding random weird-ass old items that are, like, slightly different formats than new ones, and then throwing them through the app and seeing, that broke it, this broke it, what's wrong, what's happening? You know, is the code working? Like, what's up here? And so that was, like, the first thing I did out of bed today. And I thought I would just be like, oh yeah, I'm just gonna hang out with Bear. That's what we call him, Bear. and we're just gonna hang out and we're gonna, like, you know, have a cozy chat. And it turned into this like 4 hours of us like going through old random game items and finding bugs in his code. And then next thing you know, I woke up at noon, and then it was fucking 4 p.m., chat. 4 p.m. Still no homework done. Still hadn't eaten. So I was like, well, it's late for lunch. Is the game Final Fantasy? No, it's not. Final Fantasy, I think, is a really well-polished game, and it would probably not have as many weird things that would crash this app. than the game we used to play, which is like, it's an old buggy, you know. It's not quite end of service, but it's getting there. It's pushing its limits. But yeah, it was like 4 p.m. and I was like, it's too late for lunch. What do? Do eat? No eat? Dinner? First meal of the day, dinner? Phantasy Star Online? Let's go with that. Let's go with that. Cause it's definitely some sort of online fantasy full of stars like me. Stars like me. But yeah, then it was basically dinner time. And I was like, I guess I'll just go out and I'll have fucking dinner. So I go to a local, like, sort of pubby restauranty. Break a Bell MMO from 1994. What? Yes, it's from before I was born, for sure. For sure. They knew I was coming out. They wanted to be the pre-party, pre-game for the real deal. Me. I think that's even before my big sister was born. The pre-sale bell? I mean, I guess pre-sales probably have existed for a long time. I feel like pre-sales are like a relatively new thing. I can't imagine pre-sales back before credit cards were like a big mainstream thing, right? Or like online order, you know, I feel like pre-sales must be like a relatively new thing, even though they've been around like since I've been, you know, a cognizant adult. Not even adult, even since I've been cognizant as a little person, as little cutie kid Belle. I remember there were pre-orders at like GameStop. But I feel like way back in the day in the 90s, like, you think they did pre-orders? Like, I don't know. Pre-orders were in the mail during the 90s? But most people did midnight releases. I see. Yeah, I think I remember stuff like that, like all the people camping out in front of Best Buy for, you know, the new Halo game or whatever. Mail in pre-orders. That, I don't think in all of my life have I, like, do I remember mailing in an order for anything? Maybe for, like, cookies or something for, like, Girl Scouts. But I don't think I've ever, like, actually mailed money. I mean, I guess there might have been a time in my life where I mailed a check, right? But I've never mailed cash, and I think people have done that before. Or, like, paid a bill via mail. Belle Nye the Science Gal. Hi, Cat Goes Mew. You call me a science gal, but if I'm gonna be honest, I don't know if that's very fitting. I think I was about to say Belle Nye. I think Bill Nye's a lot smarter than me. If anything, I'm an ill omen. There was an electrical fire at my workplace this week, chap. Electrical fire. If I had a nickel for every time there was an electrical fire in the lab that I work at, I'd have 3 nickels. Which isn't a lot, but it's weird that it's happened 3 times. Did it smell like fish? No. And it wasn't anything I was working. So our lab is like there's like multiple rooms. We've got like rooms with different thermal chambers, shaker tables, you know, soldering stations, RFs. We've got a bunch of stuff at our place. And I was in one room working on like the RF station, and I just hear from the next room over, "Oh, fire, fire, everyone evacuate, fire." And part of me was like, what if I just peek my head in through the door? I want to see the fire. But I didn't. I thought if I did that, they'd be like, "Belle, what the fuck are you doing, you psychopath? Evacuate like a normal human being." Do we get time off from that? No. No, not this time. And to be fair, they're like, "Fire, fire, evacuate." But really, what it was is like, it wasn't a big fire, so we didn't like burn down the building or anything. It was in one of our like environmental testing chambers. So we had the circuit going. Actually, I won't say we, because I wasn't running the test. They were doing. I had no part in this fire. But they were running it through the environmental stress testing, running the circuit, and then I guess something happened, and you know, there was some short or something, and then you see Sparky. But I think it was all contained in the thermal environmental chamber. Yeah. Like I said, there have been three electrical fires in labs that I've worked at while I was working there, and I have been a contributor to exactly 0 of them. Okay, don't pin this on me. Don't pin this on me. It just so happens, just perchance happens that these things catch on fire while I'm in the same workplace. I'm also going to say, chat, every one of these fires, I look back on and I'm like, maybe we wouldn't have a fire if someone designed this properly. Because I was talking with the people who worked on that circuit board, and some of them were like, yeah, I mean, the previous time there was a fire, it was because, you know, we didn't put in this diode so that power only comes from the power supply. So sometimes, you know, if you don't properly do the conformal code and it's not properly isolated, then what happens is the short fires off, and then you end up with power running back to the power supply. So instead of pulling power from your power supply or battery, you're pushing power into the power supply or battery, and that's not good. That's not good. So that chief who had used to work on that program was sort of laughing. He's like, "Oh man, I can't believe we keep doing this. It's so expensive to get a diode." Obviously joking, right? Diodes are very simple components. You just go and you buy them on freaking McMaster or DigiKey or whatever the hell. But he was talking about how, oh, it's so dumb that we made such a stupid error, and now we've had like 2 electrical fires from this stupid thing. But yeah, didn't pass the test. Nope. And that was this fire and the other fire at my current lab. Before that, we had an electrical fire at my previous lab. Now that was a fire, chat. Because here we're doing it like it's like small, like circuit board looking guys in a thermal chamber, and it's really like, even if it gets a little flamey, right? The most we're talking is like a 4th of July sparkler flamey. At my old lab, I'm gonna tell you a story. At my old lab, we used to work with heavy machinery. Well, I'm talking big ass, like 700 volt DC motors. And we had an electrical fire there for basically the same thing, chat. I I don't know what's up with people and not properly guarding against backflow energy into your power supplies, but it seems to be a common problem. But over there, we had the big ass 700 volt DC motors that we drove with this big ass power supply. But what happens with the DC motors is if for some reason, instead of you driving the motor with the power supply, something happens and you backdrive the motor, you get what's called back EMF. Really, really big back EMF. It's like your motor turns into a generator. And then it was the same fucking thing. It was like driving power back onto the power rail. And that thing was chunky. That thing was made to sustain 700 volts. And we fucking drove too much power into it. And that was like an actual electrical fire. We had like smoke and shit. We are melting things in our electrical cabinet. But I don't know. I don't know what it is. I don't know what it is with me and electrical fires, but I feel like I've seen in my brief couple of years as a professional, I feel like I've seen more electrical fires than most people see in their lives. Although all the ones that I've seen have been handled, you know, pretty well. They don't like burn down houses or anything, right? I think most people, if they end up with an electrical fire, they probably like lose their house. That's bad. That's not good. You say sounds cool, Mystery, and I guess it sort of sounds cool, but it's not. It doesn't sound cool when you're sitting there running a test and you start smelling smoke. You're sitting there running this big-ass heavy machinery motor and you start smelling smoke. That's not cool. That's... Everyone sitting there running the test was like... Do you smell that? Turn it off. Turn it off right now. Welders seeing a lot of electrical fires? I guess that makes sense. I mean, okay, let me ask you, chat, do you consider the welding like spark? Do you consider that a flame? Could you consider that an electrical fire? I feel like if you consider that an electrical fire, of course welders see like a ton. And I think even when, in terms of electrical fires where things have gone wrong, you probably see like, they probably see a greater than average amount. But I also feel like if you're a welder, you have your one electrical fire, maybe two electrical fires, and you hopefully learn your freaking lesson. It can't react with oxygen, but it's a lot of... Okay, here's another fucking thing. Chat, when it comes to things being on fire, what do you consider fire? Do you consider fire combustion? Or is fire, like, more generic than that? Is the sun on fire, chat? Do you think the sun is on fire? Yay or nay? Cause to me, I used to be like, well, the sun is on fire, and then I realized, well, the sun's not combusting, right? The sun is nuclear reaction, fission, fusion, whatever the frick's going on in the sun. That's not combustion, so it's not fire. But then I realized, right, I don't know if I consider fire combustion. Because when you're sitting around the campfire, right, and you've got like logs on the campfire, and the logs are burning, you've got your like flame rising into the night, smoke rising into the night, and you like hold your marshmallow, your like little s'more marshmallow, in the quote-unquote flame, which is like the red thing, the red like tendrils of that like upside down octopus thing where the red tendrils like float and flicker up. Do you consider that flame? Right? Do you consider, cause if you consider that flame, then I would argue the sun is flame, right? The sun is fire. Because the flame on your campfire, those like little tendrils of burning red, orange burniness, that's not combustion, that's just superheated air that's gone into plasma state. The only combustion is the actual log. The combustion is the actual like physically only just the log. All that like orange shit that's going up is just air that's been superheated from the exothermic reaction, right? Plasma, you ionize the air and then it becomes plasma. So I would consider that flame, even though that's not like combustion happening right there over the logs. So then I would consider the sun fire, right? Because the sun is just plasma, right? It's just superheated, ionized, freaking whatever particles. Where's our chemistry VTuber? I don't know. Someone who's better at chemistry or physics chime in. But now I feel like the sun is on fire, even though it's not combusting, right? Rusting is really slow fire. Okay, so here's the thing. Rusting is an oxidation reaction. That is not, to my knowledge, the same as a combustion reaction. Combustion reaction specifically is hydrocarbons reacting with oxygen, which is a form of oxidation, but I think rust is metal reacting with oxygen, which is a different type of oxidation. So do you consider that fire? I don't know. I mean, on some level, I guess you could consider all oxidations fire. I don't know. This is like well outside the realm of Bell's expertise. We've drastically strayed from within Bell's realm of somewhat knowledge, which was electrical fires. That's bad. I probably shouldn't be happy about that. It's probably not a good thing to go around being like, yes, I am a master subject matter expert of electrical fires. When you cut steel with a torch, it okay, but again, like you say burn, but like, what do we consider burn? Like, do we count it as fire? It might be fire, but it's not combustion. I don't know. You also say like acid burns, but acid's most certainly not a combustion. I don't think acid even counts as an oxidation, but maybe it does. I don't know. This is outside my pay grade. Someone get a chemist in here. It reacts with the oxygen and becomes slag? Yeah, but just because it's reacting with oxygen doesn't make it combustion. I mean, I think steel maybe could count as I'm hesitant, right? Because steel technically it has carbon in it, which is what I really think is like the key for combustion, right? Combustion is based off hydrocarbons, which mean carbon and hydrogen. And those, I guess, are both technically in steel, but in very, very little amounts, right? I think steel is like 1% or something of carbon. And the hydrogen just comes from wherever, right? Is acid burning not a neutralization reaction? I don't know. I thought neutralization only happened when you mix acid with bases. Right? That's what I thought neutralization was. Maybe? Because acid is, like, the thing that makes acid acid is that it turns into hydronium? Hydroxide? H plus? Is it? Wait. Hydroxide. Is hydroxide acid or base? Hydroxide is base, okay. Hydronium. Okay, hydronium I guess is technically H3O plus. But realistically that means just an H plus, right? I think. Why are we talking about chemistry? I'm not a fucking chemist, chat. Unless we're talking about battery chemistry, chemistry is like way far out of my field. or maybe what other chemistry might I know? I guess I sort of understand oxidation. My mechanical engineer ass learned about galvanic corrosion. I think that's the word. That's when you put like different metals together, right? And some of them have different electric potentials. And so it causes one to rust faster than the other. For example, if you have platinum and aluminum and you put them together, it actually makes the aluminum rust faster because it like absorbs the little trace amounts of rust that would be occurring to the platinum. Platinum's maybe not a great example because, you know, you almost think of platinum as not oxidizing at all, right? It's super, like, I don't know what the word would be, noble-ish? But the idea is if you put, like, two metals together, and one of them has really, really significantly higher electric potential than the other, then one of them will rust super fast, and the other will, like, not rust at all, because all the rust transfers from one metal to another. So that's why if you go to your, like, home water heater, you see the one, like, stick, there's, like, the metal stick. I can't remember if it's a cathode or an anode, right? But it's there near your water heater, and it gets really rusty really fast because it's sacrificial. It's literally there, and its whole job is to rust, and as long as that's rusting and continues to rust, your water heater won't rust. I think it's an anode. I think they're called sacrificial anodes. Sacrificial anode. Yeah. 07, that metal thing? Exactly, Mystery. Its whole job is to die so that your water heater may live. Similarly, if you work on a boat, you guys ever seen boats? They've got those things all over. They've got those sacrificial anodes all over. Again, the whole point is that the anode rusts so that the rest of the boat won't. I don't know how well that works, though. Because it's, like, from what I've heard is, like, there's lots of rust that happens anyway in other spots. But I think that's just because they probably go through anodes so quickly. Maybe, I don't know. I used to talk with a bunch of, like, Navy vets at some of my old jobs. We used to have a lot of veterans. And they would always be like, oh yeah, back when I worked on the ship, the one thing you would always hear every day is paint chipping, because all they do is they constantly have someone going around the ship, and they chip off all the paint, and they repaint it, because they want to make sure that it's not, like, rusting under the paint. or they want to make sure that the paint is properly covering everything to prevent rust. Which sounds super wasteful to me, to be honest. Like, you must go through a ton of paint. And also, like, that sounds awful to live on a ship and just have, like, I assume it sounds like a jackhammer, right? And, like, to me, I don't know what the paint chipper actually does, but I feel like it's some sort of smaller jackhammer where it's got like a little chisel thing and it just like shoots down and hits the paint, and that's what chips the paint away over and over again. That sounds like something the military would do. Yeah, it does. It almost sounds like something they would do, not even because they need it, but because, oh, it builds character. Put all the low-ranking guys to work cleaning bathrooms and chipping paint. That'll teach them. That'll teach them. It builds character. Sorry, I need a drink. I need a drink. But yeah, weird stuff on those ships. I know that the sacrificial anode thing is a thing that protects them from rust. But I wonder why the military does their little paint chippy doodah exercise, and I never see that on like cruise ships. Better than mopping the parking lot? Do people do that? Do people mop parking lots? Like outdoor parking lots? What's the point? What's the point? Actually, literally just doing it to waste. You're actually just ruining the mop. And then someone's just gonna immediately drive over it. Immediately drive over it. Builds character. I feel like builds character is something that old people created just to make us suffer. They're like, back in my day, things weren't as good as they are, so you should have to suffer anyway. Uphill both ways, through sleet and snow and fire and flame. Electrical fires all over the place. The military is just that way. I mean, I guess. It just seemed dumb. It just seemed dumb. And I get that they need the like military people to be tough. But can't you just make them tough by having them do productive things? Like have them exercise. I mean, I know they like exercise all. I think those guys are out there like doing weird shit like lifting logs. And lifting logs does not sound fun, but at least that's not ruining a mop. Mopping a freaking parking lot. Mopping a parking lot sounds so dumb. Anyway, that was like my adventure this week. Monday was like electrical fire Monday. And my manager was like, electrical fire? Oh, that's not good. That's not good. And I was like, what are you talking about, manager? This is great. This is the best Monday. This is what kickstarts my week is coming, and it's exciting. Exciting. Immediately start a fire when you come in. That was probably my favorite Monday in the past year for work, you know? You come in, and then they're like, oh, you came into work? Well, now you need to go out. Step outside. It's time to evacuate. Fire department is on its way. Fire department is on its way. And then you see the firefighters coming in, and they're like in their big ass, you know, fire retardant suits with their helmets on. And then our guy from the lab has to be like, oh, we reported a fire, but really now we think it's more of like a little bit of a sparky. It's fine. It's fine. You can go back to the fire station. And then the firemen are like, so there's nothing to extinguish here? Oh, okay. Guess we turned on the sirens and got in the truck for nothing. Hi, Xenotime. I was just chatting about how there was an electrical fire at my work earlier this week. And electrical fires seem to follow me around because I have witnessed three workplace electrical fires in my short 5 years of career, and I feel like that is 3 more fires than I should have seen in my life. You were doing karaoke in Japanese when the fire alarm went off? Oh no! I guess it's probably because you were spitting absolute fire. Got him! It's straight from the mixtape. I am a comedic genius. But what was I saying? Electrical fires, freaking, I feel like they're following me, man. Why are they following me? I have not created any of these. I promise you, I am not responsible. I'm responsible for exactly 0 of them, but they seem to pursue me. At this rate, I've had more than one every other year. You can't sing at all? Tell me about it, Xenotime. I did a karaoke stream Tuesday. Rest in peace, YouTube viewers. It was only on Twitch because DMCA seems scary. But I'm pretty sure I sent Penboo to the hospital with bleeding ears. Bleeding ears for Penboo. What did I want to do today for stream? Oh yeah! I'm supposed to do fucking homework, chat. But I think this is kind of cool stuff. So maybe you guys can watch me do it's not really homework, it's more like a group project. My group wants to do, we're building like this robotic arm for one of my classes. And so I told them I'd work on some of the math for it. And I'm pretty behind the game on doing the math, I promise. So let's go over kinematics of robot arms. And exactly how you can calculate their positions in motion based off of their motors. I'm not sure if this counts as forward kinematics or inverse kinematics though, chat. One sec. Really, I'm doing this as an excuse to do my group work while I'm streaming because I don't feel like I had time to do both today. Oh man, chat. Wait, I need to clear my scene. This one, bye. Goodbye, Setlost. 2 degrees of freedom. Because when we start adding in more, it starts becoming more and more painful. Although, chat, you ever get that one guy in your group who just wants to make things hard? You know what I'm talking about? Chat? We have that one guy in our group who just wants to make life hard. He's like, why do 2 links when we can do 3? But really, I mean, building the arm and doing this stuff is like actually is not even like the like focus of the class. I mean, the arm is like what we channel our focus through, because this is about what's called controls, which is like, controls is like optimizing how fast you make your arm and how fast you can go from position A to B and have as little error as possible, right? By driving your motors with the right speeds and voltages and all that jazz. So we're going over like a lot of like math and controls ideas that are mainly just like computer, right? It's mainly how controls works is your computer does a bunch of calculations on like where you are right now and where you want to be, and then it starts doing a bunch of corrections, right? But this one guy in our group is like, well, what if instead of doing 2, we do 3, and we try and make it super fast and try and cover maximum distance, and let's set all the super high goals for this 10-week class, which we're already on week 3 of. Yeah, let's do something crazy. This guy was like, yeah, let's make this arm catch a ball, which I'm okay with, right? But he's like, I want to do it using computer vision. And I was like, okay, do you know computer vision? Does anyone in our group know computer vision? And everyone's like, no. And he's like, it's fine. I'll learn it, and we'll implement it into this project in 10 weeks. Chat, they're fucking... If you're already on week 3, it's not time. It's not time to learn a brand new skill to put onto our Raspberry Pi. No. Xenotime, I think don't stop waving everything off. Part of this is just understanding that when you're in a group project, your job is not to like, you should never try and make things needlessly complex for your goal. In fact, in general, I would like to emphasize this. This is one thing that I have learned as an engineer. It is a fundamental, and you guys should stick with this fundamental in everything you do, okay? Chat, this fundamental, even outside of engineering. Start simple. Start simple. Everything simple. Simple solution. You only make it more complex when you need to. Okay, chat? I know you want to do fancy things where you want to build a radar that does frequency hopping, right? You want to do AI-enabled signal processing. I know you want to do fancy things, but I'm gonna tell you, why don't you just start with like a normal antenna receiver? You know? Just start simple, only make it more complex when need arises. Okay? I need you to if there's one thing you ever learn from me in terms of your future problem solving, it is that. Okay? We've got guys at work doing like, oh, well, we can do, crazy correction factors for all of our test equipment and calculations, and, then we can make everything super complex and super accurate. And to me, if there's an easier solution like, oh, well, why don't we just run the cable through less things? Why don't we just connect it directly so we have to calibrate for less and we have less correction factor? Why not make it easy on yourself? Ah! Okay, sorry, chat. I'm crashing out because everyone in my life insists on making things harder than they need to be, and it's costing time and it's costing money, and I am going to strangle someone. Okay, chat. Back to regular scheduled programming. Here's the name of the game. We're going to build 2 Degree of Freedom robot This thing, oh, I forgot this brush is always so fat when I first open it. 2 degree of freedom robot. X, Y. Gonna start at an origin. First link is gonna go some angle. Second link is gonna go some other angle. Right, so the first link will be some angle. Chat, I'm honestly going to tell you, I'm so bad with Greek symbols, I can never tell, like, I think this one is theta and this one is phi, right? But I honestly don't know for sure because I just don't understand half the time which letter my professors are talking about. But anyway, we've got first angle, theta 1, and our second angle will be the difference between the second linkage and the first, and that'll be theta 2. Okay? So that means our end effector, I guess we should do green for our end, is going to be Actually, we'll go in order. So here's origin, here's 0.1, and here's 0.2. Origin is always gonna be 0, 0. Our x for 0.1 will be the length of the link arm, and we'll do link 1 because maybe there'll be different lengths. Who knows? Who knows? Wait, Xenotime, what the fuck Greek letter is that? I don't even know what half of these Greek letters are. Why are we using letters that are not readily, immediately known? Is that gamma? No, I don't think it's gamma. I think gamma's the upside down L looking one. Also, quickly changing my category. Because they ran out of normal letters, Rex? I know, it's so stupid. We should have just started, I don't know. And probably lambda. It's lowercase psi? Wait, is it psi or chi or chi? Is it chi? How do we, I don't remember how you pronounce, whatever. The x of position 1, or, let's see, how do I want to write this? Hi, Higami, thanks for the raid. Oh, also, when did I stop displaying my stuff, chat? Everything's wonky, my stream is stuff. Thank you for the raid, Higami. We're doing like dumb math engineering stuff about robot arms after yapping about electrical fires and dumb stuff. Kai is different. Z? Or Xi? Or... Chat, also, low-key, I had one friend, super tangent. One friend during my undergrad who made this meme that went like super top page of engineering student subreddit because we all laughed about this one professor and this stupid fucking tendency of everyone in science and engineering. I'm gonna tell you, if this one professor would always talk about, oh yeah, so we're gonna start with 2 variables. What variables are we gonna use? U and V. Are you fucking kidding me? Why is this the default? Why is this the default? Why are the default variables for your codes U and V? Are you kidding? And then, of course, in college, right, what they're doing is they're writing on chalkboards. And it actually literally looks like this. It's U and V. And the V is not like super pointy. The V is like actually rounded like that. So you're like, what the hell is this? What the hell is this? And I freaking... Anyway, my friend posted a meme on the engineering student subreddit, and it was like, oh, we need 2 variables? Better choose U and V, and it shot straight to the top because fucking everyone is on board with how fucking stupid this is. Don't forget P and... yeah, I mean, I don't know, chat. I don't know. I also fucking literally have been doing controls courses the past 6 months, and I see shit like, oh yeah, well this is state vector X, and we're going to do modified state vector fancy X. or matrix X. Bruh. It's bullshit. It's bullshit. Sorry. Huge tangent of what I'm talking about, which is robot arms right now. But oh shit, I'm also writing on the background. Chat, you saw nothing. You saw nothing. None of this ever happened. Back to the drawing board. From get-go, from the start, we're dealing with a 2-link robot arm. Starting at origin, link 1 goes to point 1. Link 2 goes to point 2. Based off of this angle, which we'll call theta 1. And this angle, which we call theta 2. Enjoy your dinner, Higami! Rest in peace, the flashbang! Okay, Xenotime, if you refer to that as anything other than lightning bolt, you're making a whack mistake. Alright. So, the x of P1 is really simple. It's the length of that link times cosine of theta 1. And then the y of point 1 is again the length of link times sine of theta 1, right? This is just normal trig, right? Because it's just unit circle based on the length of the link, and then you have an x and a y, x comma y. That gives you this point right here. So, now if we want to calculate at the end of the arm, right, that's xp2 and yp2. So that's gonna start with is that's just going to be adding this length to what we had already calculated, right? Right, our x is just gonna be the x of the first point plus this, and then our y of the first point plus this. So we'll start with that. Our x of the first point was L cosine theta 1. And then how we calculate the new, like, addition is the length of the second link cosine theta 1 plus theta 2. Hi, Nia. I hope you're having a good night. Welcome to the stream. I'm doing stupid math stuff, which really I should have been doing like days ago as homework for a group project, but somehow we're doing it on stream and I'm just yapping through dumb math stuff about robot arms. And then our y is the same sort of thing, except instead of cosines, it's sines. Sine theta 1 plus L2 sine theta 1 plus theta 2. I need a drink, chat. I got too riled up talking about U's and V's and how professors choose really silly symbols. Okay, so now we have really easy equations for x and y of 0.1 and 0.2. What we do is we calculate what's called the Lagrangian. I'm gonna be honest, I don't really know all the crazy stuff about like who came up with this, but the general idea of the Lagrangian is it's the energy of the whole system. So the Lagrangian being kinetic energy plus potential energy, and that should stay the same unless you add a force in, right? And then if you add in a force, the Lagrangian is gonna change. But what we're dealing with our robot arm, I'll tell you specifically, is we're dealing with a configuration called SCARA. And the idea of SCARA is that all your links are parallel with the ground. So this is like sky view. And then if you look at it from like normal person horizontal view, it's like just all horizontal. So we don't have to worry about any potential energy based off of turning the links, right? Because they're always just gonna stay flat against the ground. So we can get rid of our potential energy. Oh, is it minus? Dynamics of two-link system. I thought it was plus. I also am doing this based off what I remember briefly looking at earlier in the week. So let me see. Page derivation, blah, 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 blah. Where? Further. Further. Yeah, where was it? Come on. Oh, it's kinetic minus potential. Okay. Sorry. But it's still 0, right? Potential is still 0. Flip. But yeah, regardless, there's no potential because we're not fighting with gravity with any of these links. So thankfully, not changing the map. Okay, and then the kinetic energy breaks down to 1/2 mv squared of mass 1, which will say this is mass 1. And this is mass 2. And what I sort of thought about doing was also adding in the masses for our linkage arms. But I'm feeling sort of lazy right now, and that also is going to involve not just the masses, but their moments of inertias, because they're like, they have significant moment of inertias other than being point masses. Although it wouldn't be that hard. Anyway. Kinetic energy of the first one plus kinetic energy of the second one. 1, 2, b squared. And then you can break the v squared into x dot and y dot, right? Squared plus squared. Because that's just breaking it down into a vector. Right, so no matter which way it's moving, if it's moving like this, there's just an x and a y. So all of this is gonna get expanded into 1/2 m. This bullshit. Oh my god. Chat. Oh my god. L1 sine. Okay, L1 cosine. Sorry. Cosine theta. And that's gotta be squared, so we square both of them. Plus L1 sine theta. Now, sine squared plus cosine turn into 1, so I'm pretty sure this just turns into 1/2 m1 L squared. So that's all this side. The other side turns into 1/2 m2. And then we have fucking these things squared, chat. These things are like the bane of my life. But let me quickly see if I can do this by hand. If we square the x, I think it'll be this squared, and then this squared, and then it'll be the multiplication of them both together. So that'll turn into xp2 squared, turn into L1 squared cosine squared of theta 1. Right, that's our first thing. Our second thing will be L2 squared cosine squared theta 1 plus theta 2. And then our final term, which is them multiplied together, will be... Hold on, let me clear some space! Nope, sorry. Audio went out. Whole thing exploded, Rax? Yeah, I mean, honestly, that's basically what happened earlier this week with the electrical fires. Them multiplied together will be L1, L2, cosine theta 1, cosine theta 1 plus theta 2. Okay? And then our y squared will be the same thing except signs, I think. L1 squared sine theta 1 squared plus L2 squared sine squared theta 1 plus theta 2 plus L1 L2 sine bleh sine sum of bleh. Okay, so something before I try and compress all this into here, into this tiny space, is, if I remember right, there is a trig identity. And I believe, I believe it looks something, wait, let me quickly verify. I'm actually going to steal it from him, because I don't want to get it wrong. Because clearly when I do things from memory, they're wrong. Okay, it's this one. Voice crack. This one. No, I'm not talking about that one, Xenotime. We already went over. It's this top one. with sine of one angle plus times sine of another angle plus cosine of one angle times cosine of another angle ends up with cosine of the difference, okay? So, here's what we're gonna do. We're going to take this part is the first thing, or the second thing, and this part is the first thing, right? And it was cosine A, cosine B, plus sine A, sine B, all turns into cosine of B minus A. This is our trig identity. So what you need to know is you need to know A will be theta 1, and B will be theta 1 plus theta 2. A and B. And so if we add all of these two things together, right, this first thing and that second thing, it'll just turn into cosine of theta 2. Okay? That's our big simplification here. And then you have this normal cosine squared plus sine squared, which turns into 1s for this. That's 1, that's 1. Right, so it's cosine theta 2 plus L1 squared plus L2 squared. Oh, and I think right here we're supposed to have an L1, L2. So we'll quickly correct that. L1, L2. Cosine theta 2. Okay? So the whole second thing turns into 1/2 M2, and then that. 2 cosine theta 2 L1 squared L2. Man, math is so gross, chat. Why do people do this? You have to be some sort of sicko to, like, come up with this. I say as an engineer who's basically spent more than half of my life doing glorified math problems. Okay, so that's all our kinetic energy, I think. I don't think I missed anything. Okay. AE equals 1/2 M1 L1 squared plus this. Okay. Next thing in our formulation. I'm going to continue cheating off the video because half of these things I am not very good at remembering. Okay, here is where we come in with the torques of our motors, right? So torque 1, you see at the bottom, will be the torque of a motor placed here. E1 torque, and then the motor placed here will be torque 2. And then our equation, if I'm copying, is torque 1 is equal to full derivative dt, the full derivative of the partial derivative FML. I hate... Guys, it's been so long since I've actually done calculus, by the way. Partial derivative with respect to theta 1. Theta dot. Theta 1 dot? Theta dot 1? I think it's theta 1 dot. Yeah, I think it's theta 1 dot, but maybe it's theta dot 1. And then minus partial derivative, respect to theta 1. That's torque 1. Torque 2 is the same thing, but with theta 2. Minus... Oh, should be 2. Okay, 2. Okay, so basically, in order to calculate torques, or to put torques into our equation, we need to take this bullshit, and we need to start doing partial derivatives, which is kind of awful, but it is what it is. Okay, so in this, I'm seeing only theta 2. Did I do something wrong? Wait, let me very quickly contemplate my life decisions. Moment of inertia time? I mean, if I want to add in moment of inertia, I need to add it in here to the kinetic energy. That's why God gave us calculators and computers? Okay, but I also feel like this is a good exercise in sharpening up my calculus skills, which is a terrible, terrible reason to live, to be honest. Okay, let's start with, I guess, the easiest one, I think, is this. So, partial derivative of the Lagrangian with respect to theta 1 is gonna be this. Wait. Let me quickly... Oh, I forgot a factor. Shit! Okay. So something I forgot is, since this is x dot, we also need to do the chain rule and pull out theta dot 1 here. Does it go here? Wait, let me think. So if I'm taking the derivative of this, it turns into L... Wait. Yeah, it turns into L. Cosine turns to sine theta, times theta dot. Chat, I fucked up all my equations from the beginning. Okay, whatever. It's going to be theta dot here, squared. Yeah, from theta 1. This one is going to have... Again, theta 1 dot squared. Oh no. Plus... Okay, I know how to make all the adjustments, I think. Okay. Let's quickly move our stuff. I was wondering why it seemed so straightforward. It's because I'm missing a bunch of stuff. Our kinetic energy for point 1 is not actually 1/2 ml1 squared, it's huge. It's that time times theta 1 dot. Theta 1 dot squared. And then our second one is 1/2 m squared L1 L2 cosine theta 2, and it's times theta dot 1 theta dot 1 plus theta dot 2. God, it's so ugly. Plus L1 squared theta dot 1 squared plus L2 squared theta dot 2 squared. This is, I mean, okay, so here's the thing. We do have calculators that will do, or computers that will do this calculus for us. Like, I know MATLAB can do this calculus for us. But I feel like that's cheating. Like, I could plug this into Wolfram Alpha, and I think Wolfram Alpha would do it. It would just look really ugly because I have so many variables. Same with MATLAB. But I also feel like there's some... I want to say, I don't know if beauty is the right word to it. There's some intriguingness to doing things by hand. Even though that's definitely what's causing me to make mistakes here, right? Okay, so let's do the partial derivative of this monster. It really is a monster with respect to theta 1. I'm a masochist too? Yeah. Yeah, I am. Okay. So, partial derivative of this with respect to theta 1. I think this turns into... Okay. Quickly remind me. If we do... Anyone here still remember their partial derivative calculus with, what is this? P over... Because how does theta dot 1 change with respect to theta? Does it change at all? Or is this essentially a constant? Frick! I guess worst comes to worst, we can solve the video, right? Partial? Wait, did this just turn into chain rule? Wait, no, he doesn't do the adjustment until here. And then it turns into... Oh, it just turns into double dot? Wait, no, I'm looking at the wrong part. Partial derivative of the Lagrangian with respect to theta 1 dot somehow he just dropped this squared into here, which looks like chain rule. Or not chain... yeah. Whatever, chat. I don't know the math, so I'm just gonna copy him. Okay, so it's gonna turn into E1 equals to E. I think they're different, something about being velocity and other yeah, so the double dot is acceleration, right? Angular acceleration, and the first dot is velocity. Whereas just theta is like literally just the angle. I'm just forgetting how you do the partial derivative. Partial derivative with respect to a variable, if you have its dot. Okay, wait a second. Wait a second. I need to do some quick analysis of his numbers. He has DL D theta 1 dot is equal to 3 plus 2 Bear with me, chat. He has this as his Lagrangian, because he's including potential energy. I actually should have kept it back up here. So what parts are potential energy as opposed to kinetic energy, which is what we share? Potential energy is gonna be coming from these, I'm pretty sure. That should go to 0. And that should go to 0. So when he does his Lagrangian with respect to theta dot 1, what do we keep it? It looks like all this stuff goes to here, and this stuff goes to here. Which means we would keep this and get rid of that? Question mark, question mark? Hi, Natty the Panda. Sorry, I know I'm very much not that interactive right now because I'm so immersed in this stupid math. I think this is right. Right? Anything with a G should drop out, because that's all stuff from potential energy, which we're not dealing with. And we have nothing with respect to theta 1. Plane. We only have theta 1 dots. Question mark, question mark? So that would make T1 math do be diabolical. It absorbs all attention. I mean, yes, correct. It actually makes me wonder, contemplate my life decisions every day. And it's bad It's really bad because 5 years ago when I was in undergrad, I'm pretty sure I could hang with this. And now as an old washed up hag who's been out of school, who's been out of calculus requiring courses for 5 years, 6 years. I mean, technically I took a course that used some calculus last quarter, which only was a couple months ago. But it wasn't any, like, partial derivatives. Let me quickly verify. Oh yeah, his numbers... Frick! His numbers are based off of the masses and lengths being the same. So we can't use them exactly. We just have to understand how we go from here to here. Which to me looks like we pull this square down, like when we take the normal derivatives, right? Yes. Right, because theta dot is really, EDT, or theta. If you don't use it, you'll end up forgetting most of it, but remembering just as fast because of the trauma. Exactly! That's the thing. Everything that my professors told me in school, right, chat, was that, like, if you're gonna do grad school, do it now. Because if you stop school and then you start back up again, you have to relearn calculus. And I thought little fucking naive Belle was like, oh, I know calculus, I get the concepts, I'll be fine. I'll be fine. No, not fine, chat. You actually have to relearn it. So if you're taking the derivative, wait, when you take the derivative of x, it just becomes constant, right? And if you take the derivative of x squared, it becomes 2x times whatever constant, right? So I feel like this is that same bullshit where when you're taking the derivative, it's that exponent going down. Is what my heart is telling me. With respect to... Alright, chat. Executive decision, we're just pulling the trigger, and then tomorrow, if I show this to my group mates and they're like, your math is wrong, it'll be like, whatever, at least I tried. So, we'll do dt of... This turns from 1/2 to just 1, and then we have m1 L1 squared. m1 L1 squared. And then he keeps his... Yeah, he keeps his theta. Okay, theta 1. It truly is a math thing. The result is probably a number and or letter of some kind. Exactly! Exactly. Honestly, chat, the fact that you're still here with me is an amazement. I know, like, so many people hate math. And if you're not interested in math, and you're watching my stream, you're probably like, why the fuck is this person streaming? This is not entertaining at all. So I totally understand if you're bored and you want to leave. I don't want to keep you watching boring stuff while I yap about how I'm bad at math. Okay. But exponent, we're gonna go with this paradigm of exponent goes down. With respect to this, it looks like this would be exponent 1. Oh no, it would be exponent 2. No! No, it's gonna be ugly. Okay, whatever. I see exactly its correlation, which is this thing here. And I'm pretty sure it just turns into... So, what this 3 is... was this one This one? Question mark? Wait, no. No, we don't have this one, because this one is theta 2 instead of theta 1. So this is 1. This is 1. I think it's this, right? Yeah, because this is theta... Okay. Okay, chat. This is turning into something I don't want to deal with. But let's quickly blast out. It's going to be all of this. M2, L1, L2. Cosine 2. Oh no. Cosine theta 2. Yeah. Theta 2. Yeah, and that matches this. Plus M2, L1, L2 cosine theta 2 wait. No, it's this? Okay, plus 1. L2, yeah. M2, L2 squared. Theta dot 2. What a horrible existence. Theta 2 dot plus theta 2 dot. Okay, so this whole chunk I'm pretty sure is this. And that corresponds to this specific part of this chunk and this chunk. Okay? And then what we have is this chunk corresponds to this chunk. Now all we need is this chunk and this specific part of this chunk, okay? So what we're gonna do is we're going to do plus, I think this is L1 squared theta. Yeah, it's just M2 L1 squared theta 1 dot. Right, so that's this chunk. And then our last chunk, the ugly one, is M2 L1 L2. Cosine theta? Yeah, cosine theta 2. Did I miss anything? I don't think so. Gross. Gross, chat. It's great background noise because your mind gets to focus on things that aren't instructions to summon Cthulhu. I'm not sure if you're talking about me summoning Cthulhu or I'm second monitor content and your first monitor content is summoning Cthulhu. Skill issue, I'm relearning calculus so I can do shit that my group project wants me to do. But I'm pretty sure... My suspicion is I messed up somewhere. Right? Because this 3 comes from 1, 2, 3. And then this comes from 1, 2. Where did we get 2 of the cosines? Where did this come from? Chat. I'm summoning Cthulhu because all that seems like Eldritch language that should not have been unearthed. You're correct. The moment humans pulled out a theta or whatever is like the moment in movies where the audience is like, put the book back, you're summoning a exactly. I mean, I'm pretty sure this is the moment from like Indiana Jones where you're like taking the priceless relic off the rock, and then the big giant balls starts rolling over to crush us, end humanity as we know it. I hope whatever you have on your first monitor is interesting. And that you're not slowly becoming indoctrinated into the weird parts of math where we decide... Not only does our math start with the bullshit of, like, if we have 2 variables, they're gonna be u and v. And then it goes into the bullshit of, oh, well, now we ran out of English letters, so let's use Greek ones. Theta, oh, the joy of rotational angles. Nah! I'm first monitor content? I think that's the nicest thing anyone has ever said to me, Nanny. But at this point, we're on like a co-working street at this point. I need to hunt down where I messed up. Chat. I need to hunt it down. So this was 1. This was 1. Do. You have 4/4 of your one monitor? You guys are crazy, by the way, chat. Single monitor people, I have so much respect for because, like, when I'm playing games, I at least want to have, like, Discord messages seen to me at the same time. Skill issue, you need to make a GitHub repo in case shit happens. I also have coding work to do. Mine is in Python. You know how much I know about Python? The answer is not very much. Which is really bad because the only language I know is MATLAB. That's a language I'm comfy in. And the class I'm taking supposedly used to use MATLAB, and then the professor was like, we switched off of MATLAB to Python because apparently Python is more applicable to real-world engineers. Frick, no it's not. I'm a real-world engineer. I use MATLAB. You bitch, you should have stayed on MATLAB so I didn't have to relearn a language. You're also doing Python, funny enough? Good for you. Learn a language that people won't scoff at. I remember I went to a career fair and there was a lady from Sony there. taking applicants for people, and she's like, oh yeah, do you know how to code? And I was like, I know MATLAB, and she gave me this sour look. She's like, okay then. She took my resume and threw it in the trash, basically. Basically. This is your future, Rex? I mean, you said it, not me. You said it. Oh, okay. So this got deleted. Okay. I'm seeing. This thing actually gets completely destroyed because there's no theta 1 in it at all. Which means... where did we get 1 plus? Where did this come from? Time to consult the ancient math once more. Okay. We have this because this is our x. We have this because this is our... eh? Where did it all go wrong, chat? Does it include the cutie on the bottom? Yeah, you guys are watching the best engineering VTuber. The cutest for sure, because she's definitely not the smartest. If Z were here watching, I think Z would have this done already. I need to once again look at the differences between his Lagrangian and mine. Because he has that fucking potential energy. Rah! Okay. We have... this guy is Link 1. Link 1. Knew that. We call that a fart or something? Okay, so hear me out, chat. If a fart is potential energy, is the potential to become more solid than a fart? Boulder on a cliff? Okay, 1 plus C. Where's this 1 plus C2 coming from? What did I miss that he had? That's 1 plus C2. Ignore the M's and the L's, because I'm, of course, calculating those where he's just setting them to 1s. We only have a C2. C2. Theta 1, theta 2. this comes from here. That's our C, and this is our 1. This comes from theta 1 dot theta 2. This. Where's our theta 1 dot theta 2 without the cosine? Eh? If you're not gonna be smart, you gotta be tough? Hey, I just want you to know, if I stubbed my toe, I would be crippled. I'd not only be crying, I would be on the ground, chat. Be on the ground. Also, whenever I do math chat, I always look at this. Just zoom out and look at this, and all I can think is that meme of the guy from It's Always Sunny in Philadelphia. And he's like pointing at the fucking string board. And he's like, fucking hear me out or whatever. He just... absolute lunatic. Doing his lunatic rambling and trying to... trying to put together the numbers, Mason. What do the numbers mean? Okay, also, you talked about, like, can you keep yourself from cursing? And is that something... when I became an adult, I just stopped trying to hold it in. Like, and I realize now that that's like... I think there are adults who still try and filter themselves, but it's weird to me because I actually don't even bother filtering out the curse words anymore. They just flow out of me like a river of shit coming from my mouth. Potty words. Potty words. Theta 1, theta 2. Okay, where did we go wrong? Had these turned into signs. We had those were turned into signs. Boo boo boo. I'm missing it. Chat, I really don't know where it fucking is. Where this factor of 1 came from. Where this 1 came from. Where did this 1 come from? I see this, but I don't see this. Psychopath. Normal constant? I also feel like there should be a half here. So if we take the derivative, does the cosine of something become 1? I don't think so. Okay. Quickly re-foot ourselves. I guess we have to do it, chat. We have to start from the ground up and recheck ourselves. So, kinetic energy of the second thing is going to be 1/2 m x dot 2 squared y dot 2 squared, right? Which is going to be this squared and this squared, or that dot. So the first one from the top is going to be L1 cos. So wait, cosine turns into negative sign? Yeah. Negative sine theta 1 dot. This is where I messed up the first time. And this is all going to get squared later down the road. Plus, or rather minus L2 sine theta 1 plus theta 2 and that turns into L1 squared sine squared theta 1 dot squared plus L2 sine theta 1 plus theta 2 squared. Oh, I missed a factor in this top one. Theta 1 dot plus theta 2 dot. Okay? Theta 1 dot plus theta 2 dot squared. And then it's plus L1, L2 sine theta 1 sine theta 1 plus theta 2. And it's theta 1 dot times theta 1 dot plus theta 2 dot. What an ungodly, ugly equation. But this is our x squared. Our y squared is the same thing except it's cosines. L squared cosine squared theta 1 dot squared plus L2 squared cosine squared theta 1 plus theta 2 theta 1 dot plus theta 2 dot all squared, and then plus L1 L2 cosine theta 1 cosine theta 1 plus theta 2 theta 1 dot times theta 1 dot plus theta 2 dot. Okay. So this first one is x squared. This second one is y squared. and then we add them part by part. So this part and this part are sine squared plus cosine squared. So that just turns into L1, yeah, L1 squared theta dot 1 squared, theta 1 dot squared. Okay, that's our first part. Our second part is this guy. And it has the same exact thing, because it's sine squared plus cosine squared. So that turns into L2 squared theta 1 dot plus theta 2 dot. And that gets squared. And then our last chungus is this. What color do we use? Orange. And this goes through trig identity and turns into L1, L2, cosine theta 2, theta dot 1, or theta 1 dot, times theta 1 dot plus theta 2 dot, squared. Okay. This is what I had before. So my math was... Where was my math wrong? It was right. I think, right? We had the 1. Yeah. Did we add the 2? Yeah. Oh my god, it's so ugly. It's so ugly. Is there another identity shortcut? I don't think so. The only reason I knew about that identity shortcut was because the guy from the video used it. So I feel like if there was another identity shortcut, the guy from the video would have used that one too. Although, oh, I am seeing a difference. I am seeing a difference, chat. It's this one. It's this one. This is where I messed up. It's theta 1... Ah, we need black. Theta 1 dot plus theta 2 dot. And that's all squared. Okay, okay. Yeah, and that expands to L2 squared theta 1 dot squared plus L2 squared. Oh, 2L2 squared. I see. 2L2 squared theta 1 theta 2 dot plus L2 squared theta 2 dot squared. Okay. Okay. I think we found our missing link. Maybe. Maybe. Let me quickly evaluate against the video. Okay. So we have you taken care of. This guy's done from here. This one plus C is this one plus this one. Yeah. Okay, so this one plus this C is this guy plus this guy. This guy comes from here. Okay. And then this one plus C comes from this guy and this guy? Question mark? I have a factor of 2 here, though. Why do I have a factor of 2? Oh, it's because of this. These two. Wait, no. 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 It can't be like this. Chat. It can't be like this. Surely faster to light the robot on fire? Yes. Oh shit! Shit, chat, it's almost midnight. How did we end up here? This was supposed to be fast. Okay. Putting the timer on myself to figure this out. Where these missing factors are. In the next 10 minutes, figure out where the missing factors are. Do the rest of the actual math once I know where the missing factors are. Off stream. But for now, we have to find this shit. Okay. PM, just one more game. No skill issue, this is not, because one more game is me wanting to do it. This is not me wanting to do it. This is me feeling like if I don't get it done, then I've wasted my life. Also, I know a bunch of you are from Higami's stream, Raid. Thanks for hanging around, even though this is probably like boring and or confusing as shit for you. I really appreciate it. I promise you in 9 minutes when I am finishing stream, I will send you to someone more entertaining. I already have someone in mind, I think. She's cute, I promise. She's way cuter than I am. Our theta 1 is theta 2. It comes from... Okay. Wait, yeah. Okay, it's just this. This times half turns into the 1. And then this turns into the C. Okay. Okay, chat. We found them all. Okay, so this is from link 1. This is... these two. Okay. Let's do different colors. key code this shit. Okay. Neon green. This is link 1. We'll probably reuse neon green because it's easy to keep track of. And link 1 was very, very clearly different from the others. This one comes from the sum of these two getting put together. This C times theta 1 comes from this. We'll do orange. No, we'll do pink. This 1/2 theta 2 squared comes from this guy. What's our next color? We'll start reusing neon green here. This one comes from here. And then this C, we'll use red. This C comes from here. And that's all of our factors accounted for. This 1, 2, 3, 4, 5. Yeah. 6. Okay. I'm so happy because that means that this math matches up. Chat, we fucking found our missing shit. Okay. I can't believe I just spent like 40 minutes checking whether my math was right. But I needed to. I needed to know that everything lined up. Okay. That means these two combined here. And that. So we keep this is good. Keep this. We keep this. We keep this. We keep this. And yeah, the only thing we get rid of is that. Which means that when we do our partial derivative with respect to theta 1 for the Lagrangian, we can copy his work. Which I think was here. I'm sorry, Jimmy! Thank you for hanging out. Okay. I'm happy with myself in that I figured this out, even though I fucking am nowhere near finished with doing the kinematics here. But it's late, and I actually have to do other stuff before I go to bed. So, I'm gonna send you off on a raid to a beautiful, amazing other streamer. Thank you for hanging out, by the way. Thank you for hanging out. Let me check and make sure that my stream raid is ready. Okay, we're going to Misa. Misa is a fantastic Aussie VTuber. And she sings, and she's lovely and cute and adorable. And you should give her all her love. All your love. Thank you for hanging out with me, though, in this meantime, since Higami dropped you off and my normal viewers. Thanks for hanging out. I'm sorry that I have to go, but it's... I have some stuff to take care of really quickly before I get freaking wrecked tomorrow. Have a good night, chat. Have a good night. Thank you for all the chatting and the yapping and the patience. Really, thanks a lot for your time. That's the most meaningful thing. Everyone only gets so much time, so the fact that you spent any with me is awesome. Awesome. Alright. Bye-bye. Have a good night. Be good Raiders. Bye. Bye.